Let's observe practically the magnetic field line produced by a bar magnet, actually cylindrical magnet, in 4 different cases. So the first case is when we have magnetic field line, we want to observe along the pole. We have the magnet placed left to right. So we want to observe both the ends of the pole. In third case, we have opposite poles. That is, here I have say north and south. Let me change the color. Say this is north and this is south end. This is also north end and this is also south end. Okay, so we have opposite poles aligned, right? This thus making it a big bar magnet kind of thing, but yes, there's a gap in between. So for a reason, I kept the gap. So we'll observe this as well. And at last, we have two poles, opposite poles placed in this way. So I don't know exactly which is this. Let me consider this as south, and this end also is south, or it can be north or north. We don't know. Okay, so I forcibly kept it this way. I stuck it with sellotape and to a battery and so on and so forth. So it's stiff. It's not going to move across. It will be just there. Okay. So how is that we are going to observe here is I'm going to use something called as iron file, right? So basically iron powder kept in a glass chamber. Okay, I'm going to place it above this. So I'm going to put a platform, and on that I'm going to place it so that it's visible, because if not there's a lot of color disturbance and there's a pattern and all. I have a clean slate. On that I'm going to place the iron filing, which is in a glass container. So you guys have to pause and observe. There are 4 different cases. I'll show you 4 different videos. And there's a fifth video also. It's for a ring shaped magnet. So it's just for fun. You guys can see that also. That also looks good. So pause and try to observe the patterns. If you possible, if you guys know how to zoom in, take a snapshot and take a photo, basically screenshot, and zoom into that. I'm sure most of you guys know it. So see and try to have a look at the pattern that is arising from there. Again, all of this observation helps you understand the concept better. Okay, so 4 different cases, and there's an additional fifth case that I'll be showing at the last. So you need to make your observation and post that. I'll discuss it. So now please watch the videos. Okay, I hope you guys liked it, right? So many people tell it looks like porcupine. Yes, I mean, in porcupine also we have the poking thingy. They don't cross one another. Obviously, physically they can't cross one another, right? So first case was we saw that it was like porcupine structure wherein it is pointed everywhere. It's like spike. It's something like this. So you can see clearly the magnetic field line distributes out from the ends of the magnet, north or the south pole. So they spread out from there, right? So that's what should have been observed. I hope you guys did. Then case 2, we have both the poles left arranged left to right. So you can see here it is spreading out. It is something like this straight over here and something like this, right? So I drew something like similar to this, is it not? Okay, right? I mean, I though enjoy this particular. Quite a few kids enjoy this actually. They try to touch it, but I don't let them because it kind of gets stuck with the hand, and basically the powder will reduce in quantity. So I don't let anyone touch that. At least not with wet hand. I think I let them touch in dry hand if I remember right. Okay, now opposite poles. That is, we have north and south or south and north, whatever it may be. I don't know which one. So if I keep it as one, this becomes a single magnet, right? So that's why you have one end you have a lot of spike and other end you have a lot of spike. In between you have a small spike. And if you observe carefully, it is continuous, right? And here also it's kind of something like this and something like this. If this was not there, the middle wood part was not there, it would have been something like this. It would have been one straight magnet. Actually, there are four magnets. Here too, there are two magnets. It's not a single magnet, by the way. So all of these four magnets would have been one single magnet acting like a single magnet, and the ends would have been stronger. Middle would have been just straight. This would have not been C. So what I want you guys to observe over here is it is straight. It is continuous. Okay, it's been linked. Why is that we need to observe this is when you look at when we have the same pole, right? When you look at this particular scenario, here what happens is the magnetic field lines, they are not linked. They oppose each other. Okay. So if I have to put it across as a magnetic field line diagram, so I have here north and north. So what happens is they kind of do this, you know, they almost go near each other but not touching each other. So you can see over here that's what is happening. There is a spike, there is like clash. But here when you have north and south opposite, it is continuous, something like this. So here we have north and something like this. That's what we saw over here, right? Can you see that? But when we have opposite, again, this is not crossing, this is supposed to be going up, into us. But yeah, I not drawn it that way. It's not three dimension, nah. I could have done a three dimension, but anyways. So it will be kind of clashing. It is spiky over here. It's very clear. It's not spiky over here, it's just a pole. Matlab, it is not that spiky, it's just because of a bit of disturbance over there. It's not continuous, but if not, here it's very clear, it's spiky. You can see very, it's pointy over here and all that. Because there is a clash, north opposing north, right? So they'll oppose. Let me make it a bit clear. So when they oppose, you end up with a spike, na? If you think about it. Something like that, right? That's what you are seeing over there. Okay, so yeah, what you guys need to copy here is nothing to copy per se, but yes, you guys need to have in mind what exactly happens when you have different orientation of magnet kept next to each other, and a general idea of how a magnetic field line is for a bar magnet. This is must to know. And an idea of this and other three cases, you need to have a decent idea. This is helpful for your future magnetic study. Not in this grade, I guess, if the syllabus is not changed, not in this grade, but if they change it and introduce it to you, then yeah, you might have this as well. Okay, so what do you guys need to copy? Nothing much. You need not, if you want to have a running note, you can make one. If not, there's nothing much to copy over here.